We'll have a look at a grain revision. Our vessel is to load a cargo of grain, storage factor 1.62, given our initial displacement in kg. All 5 lower hulls are to be loaded full of grain, and the tween decks are to be loaded as followed: a couple of them full, 2 part full with an ullage. And using our stability data booklet, we calculate whether the vessel complies with the minimum criteria using the maximum permissible grain heeling moment table. Before we start, we'll just have a quick look at that table. It's in our stability books, formula books, it's right at the back, and you'll see table of maximum permissible grain heeling moments. Left hand column coming down is the weight or the final displacement of the vessel, and at the top the kg of the vessel. It's fluid kg because we're going to introduce volumetric heeling moments into the problem. So we'll end up with a value of displacement and a kg, and from that we can interpolate to get the maximum permissible grain heeling moments. So we're given our displacement kg, and we're told that we're going to load all those as follows. So if we look at our tables for the grain, we can see for the holes we've got our grain capacities, the volumetric heeling moments when they're full, and also the kg of the hold. Same for the tween deck. Then over the page we have the various tween decks, and for the ullages you'll be given the volume of the grain for the ullage, the heeling moment that's created at that ullage, and the kg of the grain, because these tables represent tanks that are not the decks, that aren't full. Now this problem tells us, for instance, that number 1 tween deck is part full to an ullage of 1.5. So if I go to number 1 tween deck, 1.5, I go to the ullage of 1.5 and I can see that the volume is 1510, the volumetric heeling moments 1176, kg 10.94. So we need to pick all those values out and we need to write them up into a table. So we're given the information here that the tween decks are loaded and the holes are full. So we have the various columns here. We've got the hold. Don't forget the initial weight. Common mistake students make is to completely miss the initial displacement, because it just is the displacement and the kg, but we've still got the moments to include. Number 1 hold, we get our volume, divide that by the stowage factor, which is 1.62 in this problem, so we divide 2215 by 1.62 gives us the weight. Do the same for all these volumes, divide by the stowage factor to get the weight, multiply the weight by the kg, which gives you the moments. Fairly standard. Divide the total moments by the total weight to get the final kg. So fairly standard. These 3 columns here are a standard table for weight, kg, moments. Moments by the weight, so there's our final kg, 6.87. That's one of the 2 values that we need to use the maximum permissible table. The volumetric heeling moments we obtained from the tables. So just quickly look back at the tables. For instance, the holes, the full holes, there's the volumetric heeling moments for each table. Even though the hold is full, we have to allow these heeling moments, obviously for grain settling. So we've written down all the volumetric heeling moments and we've added them all together. Now on your formula sheet, it tells you that the actual heeling moments are the total volumetric heeling moments divided by the stowage factor. So that's the formula that we have to use. So we get our total volumetric heeling moments here, divide it by the stowage factor of 1.62, and that gives us our weight heeling moments. Now we go into the table with our displacement, 18,905, our kg of 6.87. So we're going to the maximum permissible table, do the double interpolation, and we find from that that the maximum heeling moment that this vessel is going to that it can have is 7233 tonnimeters. So once we'd gone in with our displacement and kg, which are here and here, we found that we could have suffered healing moments of 7233 and complied. Let's look at what we've actually encountered, and when we've divided the weight, the volumetric healing moment by the stowage factor, our healing moments that the vessel will actually have is 5621. It's less than 7233, therefore we definitely comply. Now, to find out the approximate angle of heel, we divide the healing moments we're going to experience by the maximum we could experience, and we always multiply that by 12 degrees, because 12 degrees is the maximum heel that we would experience at sea to comply with regulations. So one divided by the other, multiplied by 12, it means that we'll actually have an angle of heel of 9.3 degrees with those volumetric healing moments converted obviously to weight healing moments. So it's a case of looking these values up from the tables. Be careful when you've got ullages that you read off the right amounts. Don't forget your initial displacement, easily forgotten. And then it's just the one formula here, the weight healing moment, double interpolation in the tables, and that's that problem solved.